Awesome. Let's go ahead and get started. Hi, everyone. I'm very excited to talk to you all about harnessing the power of adaptive reasoning technology to proactively detect symptoms for downtime prevention, rapidly conduct root cause analysis, and understand how your services correlate with one another. A little bit about myself. My name is Jennifer Rahmani, and I'm the COO and co-founder of Thoris AI. So prior to starting Thoris, I spent a decade in defense tech as a DevSecOps engineer, where I deployed and managed monitoring solutions for large-scale government systems. During this time, I got 5 Splunk certifications, and I spent much of my days basically having to set up these dashboards and figuring out what meaningful data I had to monitor. And I would sift through noisy alerts and try to figure out what meaningful insights, I could extract and what action I could take reactively. And I would share these experiences over the years with my sister, who is a site reliability engineer for various startups. She also did her master's in artificial intelligence. And we realized that we both experienced similar frustrations with not being equipped with the right insights to do our job. And so as a result, we had to be very reactive, always in firefighting mode. Yes, my sister and I would bond over experiences whenever we would get together about infrastructure. And so like typical engineers, we thought there had to be a better way. So we started talking about all the opportunities for applying machine learning to solve hard infrastructure problems. And with this, we started Thoris. Thoris's mission is to empower engineers to apply novel machine learning technologies to improve infrastructure reliability and proactively prevent downtime. Now, I'm going to go ahead and say that, don't worry, this is not going to be a sales pitch about Thoris. The intent here is to inform how a certain type of machine learning models, such as those found within adaptive reasoning technology, can be used to proactively prevent issues and provide improved observability into root cause and symptoms. There's a lot of buzz today about AI and LLMs, and we have a bit of a contrarian opinion that I'll go into a little bit later based on our own research, testing, and customer use cases about what type of AI is best suited for certain use cases. So let's go ahead and talk about the 5 nines and high availability. I'm assuming most of us in the room here are familiar with this concept, but I still want to touch on it a bit because it is really important. Every year, we spend massive amounts of money and hundreds of billions of dollars to achieve high availability. But in reality, this is a bit of an impossible goal unless you're a company like Netflix, which can afford to spend billions. In reality, it takes 5 minutes to just log into your system and start troubleshooting and review your alerts. So what about the cost of this high availability? We all know cloud bills are super expensive. FinOps came from this. But what we don't talk about as much is the high cost of observability to monitor these large-scale cloud systems. And there's a misconception today that you need to monitor and observe anything and everything. And monitor observability tools are charging lots of money from this data ingest. But in reality, 98% of this data is useless when it comes to troubleshooting incidents. And there's also a lot of limitations that we face in the pursuit of high availability with the tools we have today. These current observability tools rely on our engineering knowledge and assumptions of how all these services correlate and all the dependencies in between. And applications are growing ever more complex and evolving. So as developers are shipping new code, it's becoming increasingly difficult to understand how to configure and threshold your monitoring and alerts. So we'll configure our monitors based on our institutional tribal knowledge, but this can quickly become stale, or these indicators could become late. And so we just end up constantly reacting to issues and firefighting, and we're just not proactive enough. So this leads to my first question to you all. I want you to raise your hand if any of you have ever been nervous about pushing a change to production. Same. Okay, go ahead and raise your hand again if the reason why you were nervous was you weren't sure what the impact of that change would be to the rest of the system in production. I love how you raised your hand very quickly. So let's talk about blast radius. Developers are releasing their code and they're not always sure how their components are going to affect other software components. So then you get incidents like the CrowdStrike outage, where someone pushed a change in production and it led to a huge outage. And it was very expensive, but it also caused a lot of reputational damage. Sometimes I think, can you imagine being a part of that development team that made that change? I think that must have been awkward, but I really feel for those engineers. And it's unfortunate because It's amazing that this type of crisis doesn't happen more often with how complex systems are today and the tools that we have. But what if your system could proactively monitor system changes and raise alerts before a full-scale outage takes place? And what if you could then respond to these proactive alerts by following a set of recommended mitigation steps? This is all finally possible thanks to the advances made in the field of machine learning. So let's talk about AI machine learning models for infrastructure teams. And these are some of the strategies. And granted, you can combine some of these if you'd like, but we're just going to examine each one of them individually. And there's pros and cons with each one of them. So you can either build a custom set of models using open source, route to LLM models provided by OpenAI, Anthropic, other vendors, or you can use a machine learning-driven platform with proprietary third-party models, such as ones that adaptive reasoning enables. Going to the first option, this has pros. This gives you a customized solution. You can avoid third-party integration, but it requires hiring data scientists who work closely with infrastructure teams or infrastructure engineers becoming machine learning experts. I don't know about you all, but that doesn't sound like a great option to me. And this isn't really a great option for most companies as it's very expensive and it can be a headache in terms of overhead and management. As engineers, we already have enough to worry about with managing infrastructure and we don't need any more responsibility. So let's go to the next option, which is routing to LLMs. Now, I think LLMs are an amazing option. We've been talking about that all day. It's super convenient. But routing to these models can be expensive, and they're also limited to certain inputs, such as natural language text. So I think these are great as a feature for certain use cases, if you're log parsing, if you're writing up postmortems, but it's not a comprehensive one-size-fits-all solution. So if you're using this option, you should look at incorporating some other options as well. And then that leads us to our third option, which is using an ML-driven platform. So this type of platform can be used by site reliability engineers and infrastructure engineers. It keeps them in the driver's seat, and it can be applied to all types of data, not just natural language text. And it provides you with lighter models that are actually cheaper to run, and they require little to maintain. They do require third-party integration, but I think the pros here outweigh the cons. So you're all probably asking, okay, what is adaptive reasoning? You keep talking about this term. So in the context of humans, adaptive reasoning is the ability to think flexibly and adjust problem-solving approaches based on new information or changing situations. What does that mean in the context of AI and ML? Adaptive reasoning describes systems that can adjust their models or decisions automatically as they encounter new data. So this is valuable in fields where changing conditions require systems to learn and adapt continuously. This allows your system to constantly and autonomously learn as conditions change so that you can proactively detect and mitigate issues before they impact your customer or end user. So how can we continuously optimize our infrastructure with adaptive reasoning? Our adaptive reasoning platform processes and analyzes application data to continuously learn and adjust problem-solving methods based on new patterns or unexpected conditions. And this paves the way for autonomous actions. Some benefits you can get as a result are faster and more accurate root cause detection, and you can also proactively prevent downtime or disruption to the end user. So how this works is the adaptive reasoning engine can monitor all aspects of the system holistically. So as components change and usage patterns evolve, it'll look for anomalous behavior that falls outside of normal distribution. It'll describe the blast radius, and it can raise an alert before potential issues arise. So this is really cool because it allows you to proactively stay highly available, so you're no longer reactively firefighting outages. But you can also apply adaptive reasoning with a live alert, with an incident. So let's go ahead and talk about a use case. Sorry, I'm struggling here to go to the next slide. Okay, let's go ahead and talk about a use case with Sally. Let's go ahead and talk about a use case with Sally, and it's her on-call nightmare. So we have a platform engineer, and her name is Sally. And Sally works at a gaming company. Some fun facts about her that may or may not be relevant. She DJs during nights and weekends, and she loves her job, but she cherishes her weekends. And Sally's on call this weekend. So our conflict, Sally gets paged on Saturday evening right before her DJ set. And the error is due to elevated errors coming from the load balancer. So first, let's talk about applying a deductive reasoning approach to solve Sally's problem. This is the approach that's commonly used today with current observability tools, and it relies mostly on Sally's institutional knowledge and assumptions. So I like to call this a needle in the haystack approach. Sally receives the PagerDuty alert, and she begins racing against the clock to log into her system, and she pulls up the alert details. She reviews the alert, starts looking at dashboards of load balancer metrics to view if there's been a traffic surge or potential latency issues. She examines various backend services to try to understand which service or component of the application may be the origin. And so she's pulling up all her observability tools. She's trying to figure out which service components are affected, which are not affected, what are the potential causes. And in this search, she starts calling up all these different engineers and developers to figure out what services and metrics are relevant. I'm sure this sounds familiar to many of us. She also starts reviewing recent deployments to see if there was a code push or a configuration change that coincided with the start of the error spike. And since she's unsure about the cause of the issue, she continues to loop in more application owners and network engineers. So they're all on the phone, deep diving, going through the logs and analyzing traces from all their various observability tools. Eventually, they figure out the fix and they implement steps to resolve the issue. But all this time, the customer is already experiencing downtime during this process. Sally's stressed because she's in firefighting mode, and she's annoyed because she just missed her DJ gig. So that leads us to, okay, what happens when we apply adaptive reasoning approach to solve this problem? How does that change things? Sally gets to log into her system, and she sees that she had received relevant alerts earlier that week from the reasoning platform. The latest alert provides an overview of the current affected symptoms across relevant affected components, such as Service A showing elevated error rates. It also shows other service components that are about to be affected, like Service B anticipating latency spikes. And it shows the suspected root cause, such as maybe a recent configuration change that's correlated with Service C. The adaptive reasoning platform is able to display all the affected services and their relationships, and it shows how the issue is propagating. And the platform has already analyzed the metrics, logs, and traces to identify correlated symptoms. Sally can see that Service A's error rates are also impacting downstream services D and F. The platform is able to list a bunch of recommendations on how to resolve this issue and in what order, so Sally knows what she needs to do to quickly remediate this. And so it gives her all the insights and reasonings and findings she needs to reduce MTTR. And this allows her to diagnose issues up to 90% faster compared to the alternative deductive reasoning approach. So since she has all the information she needs to quickly mitigate before it turns into a full-scale outage and continues to affect more customers, she's able to leave no stone unturned with mitigation. In other words, there's nothing that's going to creep back in that she should have caught earlier. So the outcome? Sally gets to go back to DJing quicker, and she's thankful for adaptive reasoning machine learning technology for giving her all the insights and findings up front to allow her to get ahead of firefighting and mitigate the issue quicker and more proactively. So there we go. So let's talk about other applications of using an adaptive reasoning platform. Well, you're able to unify all your data from your various observability tools. And this is important because many of us are working at enterprises today that have a bunch of different observability tools, right? We're not just using one tool, but it really is helpful to have one platform that aggregates all this data and makes use of it. And machine learning enables us to create models that represent a set of inputs and their corresponding outputs. So this actually means you can simulate a change before actually introducing it into your production system. And this helps with two things. One, you get an improved feedback loop to those developers, and it helps enable continuous integration. The system is able to provide all the information about service dependencies so they know how their individual components are going to affect other components. And there's an incredible opportunity to use these models to understand blast radius before pushing these changes. So let's go ahead and recap the benefits of adaptive reasoning. Adaptive reasoning allows us to diagnose issues over 90% faster compared to the current deductive reasoning approaches. And it also helps us save on observability cost. So customers now can pay for the consumption of useful metrics, and they're not just storing a bunch of metrics that may or may not be useful for troubleshooting. And you can also store data for shorter time periods. And since the system is able to deem what data points are important and what data points aren't important, you don't need to continue to monitor anything and everything anymore. And these models are cheaper to run compared to many Gen AI models. It's actually the benefit of cloud-native AI. And while Gen AI could eventually get us similar results, much smaller data models, specifically those used with other means of machine learning, are incredibly powerful while also much more inexpensive. So you end up getting higher availability for your infrastructure, but you spend less on observability and compute. And I don't know about you all, but to me, that's the holy grail and goal that I've been looking for. And just to wrap up, adaptive reasoning enables continuous automatic learning from the environments it monitors. It makes it exceptionally effective for large-scale, complex systems where reliability and fast decision-making are critical. If you're interested in learning more about this and how Thoris uses adaptive reasoning, or you want to see a demo, please reach out to info@thoris.ai. We're also going to be at KubeCon, so would love to discuss more then. But thank you all so much.
Do we have any questions?
AI related.
Sure.
So do you guys use your own machine learning algorithm to...
We have our own models. Yeah.
Got it. So the way it works, just curious, it basically, so I have my environment, it actually scans through the environment, it understands what I have, and then it, I don't know, fine-tunes or just generates its own knowledge base of it. And that's how it knows what it is and things like that?
That's a very good question. So we will integrate with existing observability tools. Let me know if you can't hear me. You can, okay. We'll integrate with your existing observability tools, all your metrics, and we have our own models that we built in-house. Eventually, we want to also build open source models available to the community as well. But we can help run analysis to figure out which model it scores higher for that particular situation or those types of metrics. And then hopefully that answers your question.
Yeah, thank you.
Good. Any other questions for Jen?
Thank you. What do you do with the problem of hallucinations and your model might not make the right decision, and then you learn that, and you learn the impact of that and the consequences of that?
So we have an over 80% accuracy rate from our own testing and with our use cases with customers. Now, there's always going to be false positives or other errors that you could come across, but we've trained on previous incident data. So now our models are able to handle unforeseen circumstances that it hasn't seen before. But since we've been working with customers from different industries and use cases and different types of infrastructure, we've gotten a lot better at being able to narrow down these incidents.
Other questions? All right. Thank you very
so
much,
much.
Jennifer.